Hey YouTube, it's Jeff at Darkmoon Metals. Today is Monday, May 21st, and we have exactly 4 days, including today, to get ready for one of our largest vending events of the year. We are going out to, actually it's up to, upstate New York. We're going to be at an SCA event called War of the Roses, and wouldn't you know it that one of our most popular sellers there happened to be our copper roses. So, we have maybe a half a dozen of these left because we haven't been making them on a regular basis. We need to make about 100 of these for this event, and we should sell through the majority of that 100. One of the problems that we have is that these can be a little time consuming to make, even though we've refined the method in which we make them over a period of time. The most labor intensive process that we have is to hand hammer the ripples into all of the petals, and this is how we're doing it now. This is our copper blank, and each rose uses 2 of these. Okay, so that's 1 done. There's 3 more on this, so there's 4 on each one. Wow, I only have 799 more to go. The hell with that. So today the project is to make a device that helps do that texturing process in a much more efficient manner. Now the price of copper has gone up since we've started making the copper roses, and we want to kind of keep our price right where it is. Normally when you try to save money so you don't have to raise your prices, you can do a couple of different things. The first thing that you can do is put more hours into your project. That way you're spending more time with labor rather than on money, but it's still costing you time. You can buy cheaper materials. Well, we're already getting our copper at a scrapyard, so we're not going to find anything cheaper than scrap. The last option that's available to us is to figure out a way to speed up the process, make it more efficient. Now, to do that, really all I need to do is figure out a way to replicate what this tool does. Every time it impacts the metal, it leaves a mark. This is the shape of the tool, and I know what the desired effect is. I have an idea. At most events, we can sell a single rose for about $20. Now, one of the things that we have found out over the years that the more people who see these, in other words, people have purchased them, they have them in their corset or in their basket, or they're just walking around with it, people tend to ask, hey, where did you get that? And the more of these that are out walking around, the more advertising we're getting. And really, our point of sale, we really want to get about 15 bucks a piece for these. So what we'll do is we will say 1 for 20, 2 for 30. And that way it gets more of them out there. And we're still making our minimum want of $15 a piece. So let's say we sold all of the roses. We sell all 100 and we sell them at the 2 for 30 price. That's still $1,000 in our pocket. So making this machine today is going to make our lives a heck of a lot easier. Not only today, but we're also looking into the future because we don't want to spend hours upon hours making copper roses. While it's true that this is still the bread and butter and our biggest seller, it's not what we're trying to focus on these days. We are trying to expand what we make, and the more things we ultimately have on our table, the more we're going to be able to sell, not just these. Now I did test this on sheet copper to make sure it would leave decent amounts of impressions and to the depth that I wanted, and it wouldn't tear through the sheet and things of that nature. And the one thing I quickly realized is the hammer has one advantage over the chisel bit here. As I'm swinging the hammer, this edge is not going to move. It's going to stay right where my hand directs it. Unless I cock my wrist like this, that's the only way I'm really going to get it to change direction. So as long as I stay consistent, this is always going to be in the same plane, and I can rotate the pedal and make it so all my impacts are right where I want them. With this, as you're using it, the chisel has a tendency to spin, leaving a bunch of random impact points on the material, and it doesn't look natural at all. It just has this crinkly effect. So we needed to counteract that first, and until we did that, making this machine was really out of the question until we solved that one problem. Once this is solved, we can move on and build a base for this. How we overcame that was to weld a piece of 1/2-inch round diameter rod to the side of the chisel bit. And what that does as it sits inside the spring, it'll move up and down, but it's not going to turn left or right very much. It's going to stay and maintain that plane. This edge is going to be exactly where I want it in relation to the work. And now that I know that that works, and the chisel bit is not going to be rotating all over the place inside the chuck, we're going to go ahead and start talking about building a base for this, where we can mount the tool, sit down, and let the tool do most of the work. Alright YouTube, this is the cradle that we made to house the tool and to nest it on the rig we're building. This is made out of 5-inch wide channel iron. At the thinnest part, this is about 1/4 of an inch thick right here. I mean, this is really solid stuff for what we're doing anyway. Now, the air hammer is going to go through that hole, come up against, I don't know if you can see it, this piece of angle iron, and we're going to use a stainless steel hose clamp to put this in place and keep it there. There's also going to be a screw on the front that's going to apply pressure to the top part of the tool to make sure it stays where it belongs. Now, in this position, it is literally sitting on the trigger. So as soon as you put air into this, it's going to start moving. There is no on and off on the tool itself. So what we did as a safety, we installed a ball valve. So this will allow us to make sure that the air is either completely on or completely off. What's going to actuate this and make it work when we want it to work so it's not running constantly is going to be a pneumatic foot pedal. So the air line will go into the foot pedal, it'll come out the output into the tool, and every time you press the pedal, the tool will simply start working. Because this is a pneumatic tool, it's going to want to bounce around quite a bit, so the base of this tool needs to be heavy, and it is going to be sitting on the floor. A friend of mine gave me some angle iron a while back, and at the time, I did not know what I was going to do with it, but I'm going to use it now to make the base of this machine. This all came out of the same piece. I simply cut it in half, and there's actually a little bit left over. And I've already used some of this in another project. This was a heavy piece of angle. I've got this cut to 18 inches, and it is 1/2 inch thick angle, and it's 6x6, so it is fairly heavy steel. Now, in between the two of these, that's going to bridge these and put them together, I have a plate of steel, and this was an old motor mount from an air compressor. The air compressor was scrapped, and this was still just kind of sitting around. I decided to save it. It is 3/4 of an inch thick, and it's about, if I can get tape measure to hook, cooperate, it's almost a square foot. So that is a fairly chunky piece of steel. This is where the weight for the base is going to come from, and what I'm going to do is stick weld all of this together. Alright YouTube, I've got this tacked together. This is how the base is going to look from the top. I got 4 tacks on the bottom, 2 on each rail. I'm going to come in with, I don't have 70-18, and I'm not sure where the heck I picked up 70-14. So, 70-14 is what I'm going to use. I have not stick welded in about, I would say, the better part of a year. It's probably going to show. It may take me a rod to get warmed up and back into the swing of things. But that's just how things go sometimes. Alright guys, so there's a lot of mistakes in this weld, and a couple of things. Number one, never having welded with a 70-14, I'm not sure what the differences are supposed to be between that and what I'm familiar with, which is 70-18. And normally I would run a couple of practice passes, but I don't have anything this thick to run a practice pass on. But I can tell what my mistakes are from just looking at this weld. I changed my arc angle about halfway through because I had propped myself up in one position, and I just, getting the motion of the electrode getting shorter and moving in towards the part as you're welding, it's something that I have not had to do in a while, and it is going to take me a little while to warm up. This is not a horrible weld. I know I've got decent penetration, but I can also tell you that my travel speed is way too fast. This bead is almost a full 10 inches long, and I burned it all the way down to the stub pretty much. But I'm supposed to be getting about 7 inches of quality weld out of each one of these electrodes, so my travel speed was kind of fast. So I'm going to change my position, get a little bit more comfortable, and I'm going to run a second pass and see if I can improve on the mistakes that I know I'm making. Alright YouTube, it is still not perfect, the second rod into the project, but there have been some improvements. Now this is the first pass I made, and as I was making this particular pass, I started out propped on the steel itself. And what happened, as I came in with my electrode, I was at an angle about here, and as I came around, I went completely into the piece and changed over, and I was sitting about here when I finished the electrode. So my angle changed throughout this entire bead, which is not good at all. You're supposed to maintain a constant angle with your electrode to the work. It does affect the weld puddle, and the weld puddle should be consistent through the majority of the weld. Now, on this side, what I did is I came in pretty much straight at a 45-degree angle into the corner and tried to maintain that the entire way. And while my arc was much better, my speed was still a little bit off. This bead should be a little bit wider. I'm going to spin it around so you can see the difference, but take a look at this with the little voids here and there. First rod, and that is the second rod. And you can tell, let me see if I could zoom in here a little bit for you. Come on camera, don't be stubborn. This is a lot more of a consistent bead than what I had on the other side. Once I'm about a half a dozen rods into this, I'm going to be fairly comfortable with it, and I should be right back to where I was when I stopped doing stick welding in the first place. But this goes to show you that stick welding is not like riding a bicycle. You have to maintain your skill level, you have to practice. And if you are going from one rod to another, whether it's a 60-10 to a 70-18, over to some kind of a more exotic rod, always run a couple of practice passes. You will thank yourself for it in the long run. But I'm going to finish welding this out, and I will get back to you as soon as this is finished. I'm going to give this some time to cool, flip it over, and then weld the underside. But this is the fourth rod in, and as you can see, I'm finally starting to lay down some passable beads. So I'm going to let this cool, go inside, have lunch, flip it over, and finish the welding process. Alright YouTube, well, the welding is all done. The only thing I have to do is install the air hammer and hook up the air supply. Now you may notice there's a round bar that's coming up in front of the main pole that's about 12 inches long. And I'll show you what that's for once I get this thing set up in the shop. And no, I am not leaving this Barney purple. This is the only can of paint I had that was both paint and primer. I had no other primer, so this is basically the base coat. This will be painted a flat black. Having things that are Barney purple in your shop is a bad thing, especially when you hang out with blacksmiths and metalworkers, because someone is going to start singing the damn Barney theme song, and with all the hammers around here, it just becomes a very dangerous situation extremely fast. So we're going to do everything in our power to prevent that and paint this thing black. Much better! Alright guys, I got the air hammer mounted into the fixture. It's tied down with a stainless steel hose clamp, which is plenty strong on its own. That should hold it in place. But just to be on the safe side, I've got an angle plate in here. It's just a straight piece of steel, about 3.5 inches long, and I dropped in a chunk of leather behind that. It's a piece of scrap leather I had laying around, and there's an Allen head screw just applying pressure to the housing of the air hammer so it won't cock either way while I'm using it. I had tried to drill a second hole, but the tap broke inside the hole. I was going to use a piece of channel iron in here and make kind of like a U-bolt setup to hold everything in place, but this works plenty good enough, and honestly I wasn't about to drill and try to tap another damn hole. It's getting kind of late and it's really overkill as it is. In fact, this whole thing is kind of overkill. So what I'm going to do is bring it into the garage, get it set up in place, and we'll show you it working. Alright folks, this is all set to go. Now, I am going to be wearing hearing protection with this, and I am going to drop the audio out of this portion of the video because this thing is extremely loud. But I'm basically trading noise for convenience. Put these on. This is a piece of high-density polyethylene. The name brand on this stuff is Starboard. It's about 6.5 inches in diameter. It's 3/8 of an inch thick. And I'm going to use this as a backing to put under the copper so I can actually press up into the chisel point. I'm obviously not going to hold this with my bare hands. I've got the air valve open. I'm going to be controlling this with the foot pedal. So let me texture this pedal. You'll see how fast it goes. And I'll show you the results. And we'll go from there. And I'll give you a tour of how this is all hooked up. And I'm doing this in real time. And there it is, fully textured. Guys, so I ran an air line, there it is, coming down from overhead, drops straight down to the floor, and it goes into the side of the foot control. Now all this is really just an air switch, on and off. I should have the same size diameter hose coming out the back and running to the air hammer, but unfortunately the 3-foot piece that I had just wasn't quite long enough, so I'm going to have to order a 6-foot whip and put that in instead. This does give enough power, being only 1/4 of an inch. I was concerned that there wouldn't be enough airflow going through the line, but it seems to work alright. But I still want this back over on my workbench because I need an air line over there as well. As far as the base, let me back out here a little bit. That is what that extra post was for. I have a whole bunch of weights that I have around the shop that I use for holding things down while I'm welding, especially if something's lopsided and I need to kind of weld out in midair. I can weigh down something on the welding table, and I've got enough stability where I don't have to worry about it falling off because I've got enough weight counterbalancing what I'm working on. But these weights never had a place of their own. Now they do. Now they're not all over the shop. Alright, so we'll shut this off. Now if somebody steps on the foot pedal, nothing happens. Well, YouTube, it seems like we've come to the end of another video. I hope you learned something, maybe got a few ideas. Who knows, maybe this inspired you to go out to your shop and build a tool that'll make your life a little bit easier. I know having this in the shop is going to literally save us hours of work. And including the drying time for the paint, this probably took me about 2 hours to put together. Dana did come in a couple days ago and she cleaned all the metal, got everything so it was all prepped and ready for welding, so that did save me a lot of time. If I had to do it all on my own, I would say it's probably about a 4-hour job start to finish. But the amount of time that this is going to save us in the future, it's just, I can't even begin to calculate it. We're talking some serious hours. On average, we make probably about 300 to 400 roses a year. And not having to hand hammer them anymore, we can make more of them in a shorter period of time. We can leverage our shop time against our expenses and actually keep our price right where it is. We don't have to raise prices. People will continue to be happy, and we will continue to sell roses and make a profit. With that being said, I am going to go out and grab dinner. It has been a long day, but I will be back in the shop soon enough, and I look forward to bringing you on our next little adventure. Take care.